Process activity mapping is a vital tool in operations management. First, we need to analyze the process. This involves recording all details such as distance, time and people involved. Understanding these elements is crucial for identifying inefficiencies. Next, we classify processes. This includes operations, transportation, inspection, delays and setup times. By identifying these categories, we can better understand the cycle times and manpower needed. We then trace both production flow and information flow. This step helps us visualize how materials and information move through the process. It allows us to pinpoint bottlenecks and areas for improvement. Finally, we simplify the flow. This means eliminating unnecessary steps and combining activities where possible. Streamlining processes leads to greater efficiency and reduced costs. In manufacturing operations, ask for this process activity map to supercharge understanding. A process flow diagram is a valuable tool for managers. It helps them understand the process and its capacity. Let's break down its key elements. Activities are the tasks carried out using available resources. Each activity has specific requirements for completion. Some activities may not carry inventory. Others may have a maximum number of flow units that can be processed within a given time. Arrows in the diagram represent the flow of the process. They show how flow units move from one activity to another. Different types of flow units can be indicated by these arrows. Inventory or buffers are crucial in a process. They do not have a fixed capacity. However, there may be a limited number of flow units that can be in this inventory at any time. This allows for flexibility in managing the process. Let's break down the key components of this process flow. First, we have the preheater. This stage is crucial as it prepares the raw materials for the subsequent steps. Following this, we encounter the lock hoppers. These play a vital role in controlling the flow of materials, ensuring that the process runs smoothly without any interruptions. Next, we move to the reactors. The first and second reactors are where the essential chemical reactions take place, transforming raw materials into semi-finished goods. After the reactions, the process continues with the flash heater to reduce the moisture content. This is then followed by discharging and finally briquetting. Once the briquettes are formed, it is released from the process. Understanding the boundaries of this process is important. These boundaries define what is included in our analysis. The level of detail we choose to include depends on the specific purpose of our study. Additionally, we must consider inventory time. For instance, if a product requires aging, like wine, this time spent in inventory should be accurately represented in our process design as a rectangle, not a triangle. In operations management, it's crucial to grasp the concepts of bottlenecks, process capacity, and flow rate. These elements play a significant role in optimizing production processes. Knowing the capacity of each resource allows managers to allocate tasks effectively. This ensures that no resource is overburdened while others are underutilized. A bottleneck occurs when a resource limits the overall capacity of the system. This could be a machine or a worker that operates slower than others. Identifying the bottleneck is essential. It helps in understanding where improvements can be made to enhance efficiency. Process capacity refers to the maximum output a system can produce in a given time. It is determined by the bottleneck. If the bottleneck can be improved, the overall capacity of the process increases. Flow rate is the actual output of the process over time. It is influenced by both the process capacity and the demand for the product. Resource utilization measures how effectively a resource is used. It is calculated by dividing the flow rate by the process capacity. High utilization indicates that resources are being used efficiently, while low utilization suggests there may be excess capacity. Consider a production line with a pile of iron ores. If the preheater processes 120 tons per hour, and the reactor processes 135 tons per hour, the bottleneck is the preheater. The overall flow rate will be limited to 120 tons per hour, despite the reactor's higher capacity. Utilization measures how effectively a process or resource is used. It is expressed as a percentage of the total capacity. Utilization is calculated by dividing the actual output by the maximum possible output. For example, if a machine can produce 100 units but only produces 80, The utilization is 80%. When we talk about 100% utilization, it means the process is running at full capacity. However, this can lead to issues. If demand exceeds supply, bottlenecks can occur. These bottlenecks slow down the entire process. In the provided chart, we see various processes and their utilization levels. The stationary reactor is highlighted as a bottleneck. This means it has the highest utilization and limits the overall output of the system. There are 3 key takeaways. 1. Monitor utilization. Keep an eye on utilization rates to identify bottlenecks. 2. Balance demand and supply. Ensure that demand aligns with the capacity of your processes. 3. Optimize resources. Aim for high utilization without compromising efficiency. Always remember that high utilization is not always the goal. Efficiency and balance are key. If you enjoyed this content, please consider liking and subscribing. Thank you.